Problem sheet 6, question 4. Consider the following transportation problem. Find a feasible solution using the minimum cost method. The problem is degenerate. Identify a basic variable that is set to 0. Find an optimal solution using the stepping stone algorithm. Okay, as we begin, we don't really know that this is degenerate, but the question has told us that. But there's nothing about the problem that tells us it's degenerate, so we should just begin to find an initial feasible basic solution, and the question asks us to do that using the minimum cost method. So what is the root with the minimum cost? That would be CZ. So we're going to fill that as much as possible, so we could put 20 in there. And that satisfies the C row, so we can tick that off. Now, out of what's left, we're not going to consider the C row, so out of the A and B row, what is the root with the next minimum cost? That would be BX. So we'll fill that up with as much as possible. So we could put 30 in there, and that satisfies our X column. So without considering the X column or the C row now, what is the root with the least cost? That would be AZ. So we'll fill that up as much as possible. If we fill that up as much as possible, we now satisfy the A row and the Z column. So instead of ticking both off, as we want to avoid degeneracy, we'll only tick one of those off. So let me tick the A row off. Now out of what's left, we're considering we've already satisfied the Z column, the X column, the A row and the C row. There's only one cell left, there's only one root left, that is BY, so we'll fill that up as much as possible. And that satisfies both the Y and the B column. So we have to tick just one of those off, and as we've ticked 2 rows off and only 1 column, we will tick the column off. That should leave 1 column and 1 row unticked, even though they are satisfied. Where those meet, that is where we will put our 0. And what does that mean? That means the root BZ is a basic variable, but it will be set to 0. Part C then asks us, find an optimal solution using the stepping stone algorithm. So in each iteration of the stepping stone algorithm, we will consider every possible non-basic variable and consider the cost of making that basic. So the first non-basic variable we will consider is AX. The root for AX will be this root, which would be to increase AX at a cost of 7, decrease BX at a cost of 3, increase BZ at a cost of 5, and decrease AZ at a cost of 4, giving a net unit cost of 5. Let's consider AY. The loop for AY will go like this. So we will increase AY, decrease BY, increase BZ, and decrease AZ. That will give us an overall net unit cost of 2. How about CX? The loop for CX will be this. And so we will increase CX, decrease CZ, increase BZ, and decrease BX, giving a net unit increase of 6. And finally, CY. The loop for CY will be this. Increase CY, decrease CZ, increase BZ, decrease BY, giving us a net unit cost of 6. Now the cost of making any of the non-basic variables basic are positive for all the non-basic variables, so we cannot find an improvement on the current solution, and therefore we have found the optimal allocation.